All right, we're going to be working with ordering and comparing integers today, and mostly we're just going to work with comparing them utilizing some rules and some number lines today. We are going to need a pencil and a marker, and then we will get started. All right, the first thing we're going to do is jot down some notes up here, utilizing what we already know about just regular plain Jane positive numbers. Right, so as we move to the right, even if we cover up all the negatives and just focus on our positives that we worked with since kindergarten, as we move to the right, our numbers are getting bigger. The value of our numbers is getting greater and greater and greater, right? If I eat 10 cookies versus 2 cookies, well, 10 cookies is definitely more. So as we move to the right, the value of our integer gets bigger. So I'm going to start by writing, kind of making this a little visual. I'm going to write bigger, but I'm going to also tie in the fact that as I move to the right, my numbers are getting bigger and bigger and bigger and bigger as well. So I'm getting bigger and bigger and bigger as I move to the right. And then just the opposite. If I, again, block off all my negatives and I just look as I move to the left, what's happening to the value of my numbers? The value is getting smaller and smaller and smaller and smaller. So as we move to the left, the value of our integer gets smaller. All right, so I might start over here and kind of just work it backwards, making it a little visual. And I'm getting smaller and smaller and smaller as we move to the left. Okay. Then what we did in class is come up with some rules that we can apply to comparing positives and negatives and even to the number 0 all the time. What are some concrete rules that we can write down that always give us a yes or no answer? So one thing that the kiddos said was that 0 is always bigger than a negative. If we think about money, well, it's better to have $0 than to owe your sibling $100. So 0 is always bigger than a negative. Is always bigger than a negative. And I'm just going to use kind of like a little tile there with a negative symbol. The second thing we did was compare positives versus negatives. And even just looking at here, I know that a positive number is always going to be bigger than a negative. So positives are always bigger than negatives. Always, always, always. And then we can say just the reverse of that. Negative numbers are always smaller than positives. Always, always, always. Right, and then the last one is probably the trickiest one. We're pretty comfortable, I'm sure by now, comparing positive numbers because we've worked with those since kindergarten. What's going to be new and a little bit tricky sometimes is comparing negatives against negatives, because it works pretty much the opposite. Because the bigger the negative, the smaller the value, right? The bigger we go, the smaller the value of our number. We can think about it like debt. The bigger our debt gets, the smaller, the less amount of money we actually have. So I'm going to put this in quotes. The quote unquote, the bigger the negative, the smaller the value. And I'm just going to circle that one because that is a pretty important one, right? We could think about it like money. Again, would you rather owe your sibling $10 or $1? Right? $1 is going to be better. It's going to have a bigger value. If you owe $10, that's worse. It's more negative. It's going to mean that you have even less money because you've got to work your way all the way back to zero, which is going to take longer the farther and farther and farther away you are from zero. All right, so there we go. Order and comparing integers. We have some really basic rules for comparing positives versus negatives and negatives versus zero. All right, great job.